Hello learners, I'm Akash. I completed my BTech from NIT Rourkela in the year 2020. Currently, I'm a mathematics teacher. Now let us see how to solve this given question. We need to show that the tangent at px1 comma y1 on the curve root x plus root phi is equal to root a is x1 power minus 1 by 2 plus y1 power minus 1 by 2 is equal to a power 1 by 2. Okay, this is what we have to show. Basically, what this question is asking is we have to find out the equation of tangent at the point this, okay, and for the curve this root x plus root y is equal to root a. Okay, now how I'm going to do it is sorry for that. First, to find out the tangent, okay, to find out the tangent I need slope of the tangent. So I'm going to first find out the slope of the tangent. Given curve is root x plus root y is equal to root a. Okay. Now as you guys are already familiar, slope of tangent is nothing but dy by dx. Slope of tangent is nothing but dy by dx. So let us find out dy by dx. How? We'll differentiate both sides of this equation with respect to x. Differentiate both sides with respect to x. Now if I'll do this, a derivative of root x plus derivative of root y is nothing but a derivative of root a. Okay, root a is like a constant. Root a is a constant. And listen, what is derivative of root x? Derivative of root x is nothing but 1 by 2 root x. Derivative of root x is 1 by 2 root x. Okay, so 1 by 2 root x plus, now derivative of root y is 1 by 2 root y. That is okay, but here differentiating with respect, here we are differentiating with respect to x, but the variable is y. So for that case I'm going to get here 1 by 2 root y into dy by dx as per chain rule. Okay, and derivative of root a, I already explained, root a is a constant. So since this is a constant, derivative of constant is 0. Fine. So now send this 1 by 2 root x to the RHS. So this, I would get this like minus 1 by 2 root x in my RHS. Okay. Now this 2 root 1 by 2 root y is there in the LHS, right? Now this 2 root y, send it to the RHS. So here it is in the denominator. When it will go to the RHS, it would become a numerator. Okay. So dy by dx is nothing but minus 2 root y by 2 root x. Okay, fine. Now 2 will cancel and dy by dx is nothing but minus root y by root x. Now this is slope of tangent to that curve, to this curve root x plus root y is equal to root a. So this could be at any point, but here we are looking for equation of tangent at the point p x1 comma y1. In case you guys remember, see, our question is that we have to find out tangent at p x1 comma y1. Now if that being the case, basically I need to find out slope of tangent at the point px1 comma y1. So my point is x1 comma y1. Slope in general is minus root pi by root x, but my point is x1 comma y1. So slope of tangent at px1 comma y1 is nothing but m is equal to minus root y1 by root x1. See, in general slope is this, but our point is x1 comma y1. So in place of x put x1 and in place of y put y1. So I get this slope. Okay, let's go. I know this is a serious topic, but we can smile a little and make things a bit lighter. Okay, so that we can have learning in a relaxed manner. Okay, please have a little smile on your face. Chal, now let's go. Now I got my slope. Now as you have learned in straight lines, here we have the slope. Okay, I have the slope of the tangent. I also have the point at which tangent needs to be found out. The equation of tangent needs to be found out. So using slope point form, okay, point is px1 comma y1 and slope is m equal to minus root y1 by root x1. So using slope point form, what is that? Y minus y1 is equal to m into x minus x1. This is how I am going to get the equation of tangent. Now what is my m? M is nothing but minus root y1 by root x1. Okay, now y minus y1 is nothing but minus root y1 by root x1 into x minus x1. Okay, now from here on some solving is involved and I sincerely request your attention. Okay, this root y1 is there now. Send it to the LHS. Here it's in the numerator. When it will go to the LHS, it will go to the denominator. And this minus is there. Minus, just keep it here. Fine. Now, Now just nothing special, just multiply the minus with these two terms, like minus x, minus of minus x1 is plus x1, so minus x plus x1. I just wrote this as x1 minus x. See, here it is, x minus x1. If I'll multiply minus, so it would be x1 minus x. Okay, minus x plus x1, I wrote it as x minus x1. Fine. Now what I'm gonna do is I'm gonna split the denominator. So this would be nothing but y by root y1 minus y1 by root y1. Here x1 by root x1 minus x by root x1. Okay. So what I'm gonna do is I'm gonna bring x and y on one side and x1 and y1 on one side. Now if you see here, there is y and y1 on the LHS, there is x1 and x on the RHS. What I'm gonna do is just bring this x to the LHS and bring this y1 term to the RHS. Okay. Now here it is minus x by root x1. When I'll take it to the LHS, I'd get x by root x1 plus y by root y1, and here you see minus y1 by root y1. Send it to the RHS, I'd get x1 by root x1 plus y1 by root y1. Okay, I hope things are making sense, or is it just going above your head? Is it going into your head, or is it going above your head? I hope it's going into your head. Okay. Now x by root x1 plus y by root. Now under root, see, under root of any term, it basically means that it has, like, we can take it as power 1 by 2. For example, root 2 is nothing but 2 power 1 by 2. Root 2 is nothing but 2 power 1 by 2. So likewise, root x1 can be taken as x1 to the power 1 by 2. Okay, x1 to the power 1 by 2. So x by x1 to the power 1 by 2 plus y by y1 to the power 1 by 2 is equal to, now you see, there is one thing to notice here. What is that? Is this x1, I wrote it as x1 to the power 1. I wrote x1 as x1 to the power 1. Now why did I do that? You will find it out. And here you see in the denominator x1 to the power 1 by 2, and here again y1 to the power 1 I wrote it, and here it's y1 to the power 1 by 2. Okay. Now what is so special? What is the special thing which I mentioned? Why I am writing like this as x1 to the power 1? I am not just keeping it as x1. We can write it, right? Like a power 1 is nothing but a. I can write it as a power 1. So 2 I can write it as 2 power 1. X1 I can write it as x1 to the power 1. Okay. Now what I'm going to do is, listen to me carefully. Here if you see, this is x1 to the power 1 by x1 to the power 1 by 2. So this is of the form a power m by a power n. Okay, a power m by a power n. What is a power m by a power n? A power m by a power n is nothing but a power m minus n. Okay, it is a power m minus n. So in the next step, you would see that this would be nothing but x1 to the power 1 minus 1 by 2. This would be nothing but x1 to the power 1 minus 1 by 2. Likewise, y1 to the power 1 by y1 to the power 1 by 2 is nothing but y1 to the power 1 minus 1 by 2. Y1 to the power 1 minus 1 by 2. So that's what you would be seeing. Okay. Now let's come to the LHS. The RHS, I told you what is going to happen. You see, here I have x by x1 to the power 1 by 2. Okay, I'll just show it to you. So that, as I mentioned, x1 to the power 1 minus 1 by 2, y1 to the power 1 minus 1 by 2. Now see, this 1 by x1 to the power 1 by 2 is nothing but x1 power minus 1 by 2, because 1 by a power m is nothing but a power minus m. 1 by a power m is nothing but a power minus m. So this 1 by x1 power 1 by 2 is nothing but x1 power minus 1 by 2. Okay, when this will come to the denominator, when this term in the denominator will come to the numerator, the power would become, we would get a negative in the power. So x1 power minus 1 by 2. So x into x1 power minus 1 by 2 plus, again say likewise, y into y1 power minus 1 by 2 is nothing but equal to what you guys can see. Okay, chalo. Fine. So x into x1 power minus 1 by 2 plus y into y1 power minus 1 by 2 is nothing but my 1 minus 1 by 2 is 1 by 2. So x1 power 1 by 2 plus y1 power 1 by 2. Okay. Chalo. Now we're almost there. have a little smile on your face. It's good to relieve stress and calm you. Fine, and don't forget to breathe. I also need to breathe a little. Okay, let's go. Now, fine. This is what I have. Again, you see, I have these powers, right? X1 power 1 by 2, I'm writing it back as root x1, and y1 to the power of 1 by 2, I'm writing it back as root y1. So in the RHS, you would be seeing this now. You see, we are finding the equation of tangent at the point x1 comma y1, which is on the curve. At the point x1 comma y1, which is on the curve. Now, what does that mean? What is our curve is? Since our curve is root x plus root y equal to a. Now see, this point P lies on the curve. This point P lies on the curve root x plus root y is equal to root a. Now, what does this mean is, in place of x and y, if you will put this x1 and y1, that means this equation will be satisfied. Okay, so in place of x and y, put root x1 and in place of x and y, put x1 and y1. So I would get root x1 plus root y1 is nothing but root a. Now, if you'll observe, what we have in the RHS here, we have root x1 plus root y1. Now, what is this root x1 plus root y1 is nothing but root a. Root x1 plus root y1 is nothing but root a. Okay, so with that in mind, so my final equation of tangent is nothing but x into x1 power minus 1 by 2 plus y into y1 power minus 1 by 2 is nothing but root a. This is what they asked us to prove, and we have proved it. So, the favorite statement of almost many people, hence proved. Hence proved. Finish. Okay, fine. I hope you guys had a little fun along with learning. Okay, I tried my best to make sure that I put in some amount of fun and some knowledge as well. Fine, and I went in detail, and I went from the basics. I shouldn't say from the basics. I covered the basics at least which were required. Fine. And in case you like this video, please hit the like button. It would encourage me to make many more of such videos. And if this is your first time coming across to my channel, please do subscribe to it. And one more thing, I should say this is the first video in which I have tried to smile and make this explanation. So in case if you feel that I should explain more videos by smiling, so please do put that in the comments box. I'll take it as a feedback and make sure that I have a smile on my face, and make sure that you guys also have a smile on your face while you are studying. I know this Max B is a difficult subject. We get serious like this, but still, it's okay to have a little smile, and make sure that we go through things. Right? It doesn't hurt to smile, and it doesn't cost. It's free. Okay, so thank you very much.